Okay, hello everyone. Right now is Dubai time, 1:50 p.m. And I was in Dubai for the 28 Blue Zone area. And right now in our digital cross-screen pavilion, we will talk about the EV, electric vehicles. And because our theme is the emerging technology to tackling climate change, we focus on the EV for this event. And we have some very important speaker. And one is the general manager from the PEGATRON, Franco. And later on, I would like to invite Dr. Michaelowa. He is a research director of the Perspective Climate Group. And later on, I would like to introduce Shih, and he is a project manager of the corporate communication Delta Electronic. Delta Electronic have lots of the side event and the introduction, and they are very successful in the EVs. And so I would like to have the video from the Franco line, and he's the general manager of the PEGATRON. Okay, let's play the video. And PEGATRON right now, just I know, they are the major supplier of the Tesla. I know. Maybe we can. Okay,
Emerging
please.
technologies to tackle climate change, the growth of electric vehicles and mobility innovation.
Good afternoon. My name is Franco. As the BU head of the PEGATRON Automotive Business Unit, I joined ASUS Computer from 20 years ago, then transferred to PEGATRON for computer business. From 2009, PEGATRON started engaged with automotive products. Step by step, we have more and more automotive customers, and my team become an automotive dedicated BU. Today, I'm so pleased to join COP28 conference for emerging technology to tackle climate change, EV. In the past, I saw the change of automotive from ICE to EV. The growth of EV are significant. Also, the innovation of smart mobility, like CASE, connected, autonomous, sharing EV, just leading the trend and change the mobility pattern. Thanks for your join today, and we can expect better tomorrow.
Today's agenda: first, net zero carbon emissions 2050, the growth of electric vehicles. Second, transformation from ICE to EV, electrification plus intelligence, CASE. Third, a future of mobility for carbon reduction, eVTOL and robotaxi. Net zero carbon emissions 2050, the growth of electric vehicle. Shifts to more sustainable modes of transportation, the electric vehicle sales are taking off. Electric vehicle sales are on pace to reach their 1.5 degrees Celsius aligned target for 2030. Declines in cost, improvements in range and the expansion of charging infrastructure have all contributed to this recent exponential growth, with Norway, Iceland, Sweden, the Netherlands and China witnessing the fastest increases. Global EV sales market, 2013 to end of 2023. In 2022, 10.52 million EV were sold, with an annual growth rate of 55%, exceeding 10 million for first time. The compound growth rate from 2017 to 2022 is 53%, from 1 million to 10 million vehicles in 5 years, and the market share rate increases from 1.3% to 13%, 10 times. In addition, IEA also predicts that sales volume will reach 14 million units in 2023. Transformation from ICE to EV, electrification plus intelligence, CASE, electrification, strong demand for batteries, sufficient charging environment, powertrain integration, shared chassis platform, flexible styling in space, intelligence, smart e-cockpit, software and hardware integration, vehicle networking, V2X, ADAS level 0 to level 3, ADAS level 4 to level 5. Convenient charging environment. In January 2021, Biden promised to build 500,000 electric vehicle charging stations in the United States. In March 2021, VW Group announced that they would invest €400 million by 2025 to expand 18,000 DC fast charging stations across Europe with the assistance of the 5 major charging network suppliers. In November 2022, Tesla announced that it would rename its TPC charging specification to NACS, North American Charging Standard, and open it to other brands and charging operators for adoption. Then, in May 2023, Ford, GM, Rivian, Volvo, Mercedes, Hyundai, BMW, Toyota and other car makers successively announced their participation in NACS and follow with more carmakers joined. In September 2023, the oil giant BP purchased $100 million in supercharging station from Tesla to strengthen its electric vehicle charging infrastructure. Powertrain integration. From independent motor electronic control systems to integrated 2-in-1, 3-in-1, and even multi-in-1 systems, highly integration is the development trend of motor electronic control systems. Although it will face considerable challenges, such as heat dissipation, EMC, etc., but it also has the advantages of increasing system efficiency, reducing volume and weight, and saving energy. To achieve independent and precise control of 4 tires by 4 motors, a more precise control algorithm and an electronic control system with higher perception capabilities are needed. Only under the comprehensive control of algorithms, motors, and electronic controls can millisecond-level high-speed adjustments to the tires be achieved, and complete relevant actions. Shared chassis platform. Each carmaker has launched a common platform for electric vehicles to shorten the development time of new models, which could simplify the manufacturing process and reduce costs. In addition to cross-brand use platforms within each group, cross-group cooperation models have also begun. Toyota shares e-Tienga platform with Subaru. VW Group shares MEB platform with Ford. Hyundai shares eGMP with Kia. GM shares Ultium platform with Honda. Geely shares C platform with Volvo. Stellantis developed the STLA platform. BMW developed new E-Class platform. Mercedes-Benz developed MMA platform. Smart e-cockpit. Under the trend of e-cockpit technology, large-size display, 1 ECU support multiple screens, smart integration with audio, video entertainment, personalized settings, human-machine intelligent interaction, etc., have become the focus of intelligent cockpit and will also develop into the third living space. The major 4 trends of the smart e-cockpit: integration, interaction, entertainment, individualization. Software and hardware integration, SDV. Software control such as OTA, algorithm, sensor fusion plays an increasingly important role in the system, and the vehicle electronic and electrical architecture, EEA, has also moved from distributed ECU to centralized and domain fusion architecture. Therefore, the integration of software is more important, so car makers also plan to take the lead. What is more important for electric vehicles is software, because it can give unlimited imagination to vehicle and can also bring new business models to car maker. Ford CEO pointed out on July 2023 that the main reason why Tesla is ahead is not the car-making technology, but who has more powerful software capabilities, SDV. If you want to keep up with Tesla's advantages, you must take back all software development rights and write them yourself. No car maker has ever written software like this before. Vehicle networking, V2X plus 5G. Smart EV will transform into the largest intelligent information terminal and become an important node in the Internet of Vehicles, smart transportation, smart city, and develop a new type of smart travel service model. The era of software-defined vehicles is gradually approaching, and smart electric vehicles are expected to become the largest mobile intelligent information terminal and the first 5G Internet of Vehicles application scenario to be implemented. ADAS, Level 0 to Level 3, XPeng, the last technique before self-driving released. can realize full scenario assisted driving from parking space to parking space. Its full scenario intelligent assisted driving can cover underground, surface parking lots, urban main roads, secondary roads, branch roads, urban expressways, and other road scenes. It will also open up the connection between parking and driving states to improve the overall traffic capacity of vehicles and bring a safer and smoother user experience. The Drive Pilot technology launched by Mercedes-Benz can use GPS, precision mapping, LiDAR and other technologies, as well as several cameras and other sensors, to sense the conditions of surrounding vehicles and objects, and perform automatic assisted driving behaviors. It is the world's first automatic driving assistance system to pass the International SAE Level 3 certification, Germany, Nevada, California, USA, but it is only allowed to be used on highways. ADAS, Level 4 to Level 5. The use of electric self-driving cars for freight logistics has been applied in actual scenarios, such as the Nuro plus Uber Eats delivery service on September 2022. Manned self-driving cars such as Waymo and Cruise have obtained permission to operate on the road in California, San Francisco, on August 2023, Level 5. This result will once again change the appearance of urban traffic. Self-driving valet parking system, Germany, Stuttgart Airport P6 parking lot, Mercedes-Benz and Bosch jointly created the world's first commercial Level 4 self-driving parking service, which has been in operation since November 2022. A future of mobility for carbon reduction. eVTOL and robotaxi. eVTOL, electric vertical takeoff and landing, eVTOL, which can take off and land vertically on the spot, is expected to be the next new mobility trend after electric vehicles. In recent years, car makers and airlines including Audi, Hyundai, Stellantis, GM, etc. have actively invested in related research and development because they are more in line with the needs of environmental protection, energy conservation and carbon reduction than traditional fuel helicopters. Volocopter is targeting the 2024 Paris Olympics and is expected to launch an air taxi service. Joby received an order from the U.S. Air Force and will begin delivery in September 2023. It is mainly used for the transportation of personnel, materials. Archer is partnering with Stellantis, United Airlines, and Boeing to launch an eVTOL air taxi in 2025. Aleph Automotive has launched vehicles for both land and air use, and will convert mobility types based on demand. Robotaxi. Tesla's robotaxi. The concept is that when the owner does not need to use the car, he can use the idle Tesla car to pick up and drop off passengers through the autonomous driving system, FSD. It is expected to increase the battery mileage utilization to 5 times the current level, and at the same time as a shared car, a Tesla car can save 41 grams of carbon emissions per mile than a private car. Tesla's charging station. It has provided 8.3 billion emission miles in 2021 and has saved 3.9 billion kilograms of carbon dioxide, CO2, and all charging stations use 100% renewable energy, such as solar energy. The charging process of EV is less carbon intensive and environmentally friendly. In addition, Robotaxi plus charging station plus solar energy can create a complete energy saving and carbon reducing mobility ecosystem. Thank you for your attention.
Okay, thank you, Franco Lai. And this video is quite interesting and wonderful. Robotaxi from the Tesla. We hope we can take it. Had anybody take it before? No, we never meet it before. Okay, right now I will give the floor to the Axel Michaelowa, and we also want to talk about something like this. Please, Michaelowa, Professor. Yes.
Thank you. So we have been hearing of the technological advances for electric vehicles, and now I will get into how international carbon market can generate revenues for projects involving such vehicles. So I will have a short discussion of the general need to decarbonize the transport sector, then how the international carbon market can principally support dissemination of e-vehicles and potential challenges and how to resolve them. So road, maritime and air transport have been internationally responsible for about 25% of total energy-related greenhouse gas emissions. We know that under business as usual, transport emissions are expected to increase due to the growing number of private vehicles sold in developing countries. We see increased urbanization income. We see improved road transport infrastructure. Just looking at our host city here, if you would have come here 50 years ago, you would not have seen many asphalted roads. You would not have seen a relevant number of cars. And now this is dotted with 10-line highways and the most modern vehicles. And of course, our host city also shows that it's not easy to build high-performance public transport infrastructure. We see that now they have the metro system. That was the first metro system in the Arab world. It is having very high efficiency. I'm really impressed to see that it runs one train every minute, which is more than in any other public transport system that I've seen in the world. But still, it's only one line, and the city is, of course, much larger, and the challenge of feeder services is very visible here. Of course, Taiwan, I think, has excellent experience with setting up high-quality public transport infrastructure, high-speed railway, also good bus and metro systems in the largest cities, but still. And the local pollutants from internal combustion engines have a very detrimental effect on health in urban areas. So, of course, the co-benefits of shifting from internal combustion engines to electric vehicles are huge. We also see that a number of countries actually want to reduce import of transport fuels. Most countries don't have domestic sources of oil that can then be used for transport fuel. So that, of course, gives an opportunity to address this issue of cost of these imports. So there are, of course, significant challenges also with regard to the e-mobility solutions. For some sectors, e-mobility is not easy to achieve. We know the debates about airplanes. We know the discussions about heavy freight transport vehicles. For example, in Germany, there is one corridor of 30 kilometers of highway that has overhead lines for trucks, so they would run a bit like these electric trolley buses that we've seen in many cities in the past. But yeah, it's not straightforward. Of course, also the cost for the electric vehicles still relatively high compared to the internal combustion engines, but the gap is decreasing. And we've seen countries that have actually been able to set up an array of policy instruments that enables rapid penetration of electric vehicles. Norway, for example, has been a front runner in an integrated approach to electric vehicles, rebates, import tariff reduction, the possibility to use urban toll systems without being charged, or tunnel tolls. Norway is a very mountainous country, so they have long tunnels that usually take tolls. So Norway was really showing how to set up a system of incentives that would quickly expand electric vehicle use. And of course, mainland China has been very successful in replacing ICE motorbikes by electric motorbikes. So I think we have some really good examples how that can be done. One critical aspect, of course, is the development of the charging infrastructure that usually generates high costs for the public purse. And of course, if we have an electricity system that is very carbon intensive, then electric vehicles may even increase carbon emissions. So we need to see, in which countries actually do we have high share of renewable electricity, and there, of course, the emission reduction component of electric vehicle will be particularly high. So just to say electric vehicles on their own are not necessarily a silver bullet solution for greenhouse gas reduction. There needs to be an integrated approach to actually resolve the transport challenges in terms of greenhouse gas emissions. Now, getting into the specific topic of carbon markets, there is an important window of opportunity for the international carbon markets to support e-mobility, especially if we look at integrated projects, not just the diffusion of electric vehicles, but also a package of electric vehicles and charging solutions. Because currently, if one would look at just the cost over the lifetime of the vehicles, including, of course, the cost for fuel, their electric vehicles may already be cost competitive. But if you include the costs that are needed to also build up the charging infrastructure, then this would not be the case, and therefore the combined activities would qualify with regards to additionality. In the voluntary carbon market, additionality testing is done through so-called common practice tests. They look at the penetration rate, and for CDM, we had penetration rate thresholds of 2.5%. Under the VERA system, the Verified Carbon Standard, it's 5%. And these, of course, are problematic because, yeah, once the technology gets attractive, of course, initially the penetration is below that level, but still it's already quite commercially interesting to engage even without the revenue from the carbon credit. We also see a lot of development in monitoring, reporting, verification technologies that would make such projects attractive. We can have the batteries sharing data with regard to the charges and consumption and the travel distance. And this, of course, could facilitate monitoring large number of vehicles, because previously under the international carbon markets, one had to do complicated transport surveys that would generate high transaction costs. And now it could be directly integrated in the development of the technology itself. And also this type of MRV would generate high accuracy. So, of course, there are also some challenges with regard to e-mobility in carbon markets. The greenhouse gas reduction for a single e-vehicle is relatively small. For the e-motorbike, it would be about 1 to 2 tons CO2 per year. For e-buses, it could be 50 to 60. But experience shows that you would need at least 10,000 tons of CO2 reduction to make a project attractive under international carbon markets. So that means, yeah, you need to have several thousand motorbikes and several hundred buses to make this relevant. So a programmatic approach would be required to actually exceed these thresholds. And then, of course, there are some questions related to the life cycle sustainability of the technology. So, of course, there is a lot of debate about batteries. The resources like lithium mining that generates issues, also the recycling of the batteries at the end of their lifetime. So this is an issue which so far has not really been addressed in the international carbon markets. In our view, the promising subsectors would be replacement of ICE motorbikes by electric motorbikes. And this could be related to fleets. In many developing countries, we have motorbike taxi fleets. Southeast Asia, it's quite common, but in Africa as well. And of course, this is attractive in low-income countries or countries with high urban densities. Buses, and there, of course, we see an increasing interest in electric bus projects around the world, or also taxi fleets. I've quite a lot of activities in Vietnam, and I was really interested to see that in Vietnam, you now have emergence of electric-only taxi companies. Also in India, and the scale up of such approaches could, of course, be considerably accelerated by international carbon markets. Then, of course, you should focus on countries with a grid dominated by renewables. Ideally, the grid would have even some surplus. So small island states could be very interesting. And I note the Article 6.2 pilot of Switzerland with the Caribbean island of Dominica, which is for a whole island electric vehicle strategy. And of course, those countries that have their grid dominated by hydropower, we see it in Ethiopia, we see it in many other African countries. So, as said, we see in the first pilot activities for Article 6.2 electric vehicles coming in. There is a Swiss-Thailand transaction on e-buses, and I hear that yesterday they've sold their first ITMOs. And we have the Dominica project, which I already mentioned. So with that, I would like to thank you, and I'm looking forward to your questions.
Thank you, Michaelowa. I'm wondering, such as kind of mechanism to switch to the e-mobile, we should think about a carbon market, right? So how to do it? Because right now in Taiwan, we do not have a policy like this. Do you have any kind of suggestion about the future? Any kind of
So with regards to Taiwan, of course, well, one can directly integrate the transport sector in the carbon pricing system. This has been done in European countries. So we have either the transport sector being covered by a trading scheme. So the EU now has a second layer of trading, which will be on transport and buildings. That's usually done in an upstream manner. So, of course, that doesn't give the direct incentive to the electric vehicles, but it gives a disincentive to the internal combustion engine vehicles. One could, of course, levy a carbon tax directly on fuel for transport. We know almost all countries have some fuel taxes, so this is a very known and long experienced policy instrument to have an adder that would take into account the specific emissions intensity of the fuels. One could, of course, also allow electric vehicle producers to generate offset credits directly against a carbon pricing system in Taiwan. So there are many opportunities that one could consider.
Okay, thank you, Michaelowa. And I know you have another segment. Okay, thank you very much. Okay, right now I will give the floor to Johnny, and he's from Delta Electronics. Johnny, the floor is yours, please.
Hello. Okay. Good afternoon, ladies and gentlemen. I'm Johnny Shih, Deputy Spokesperson of Delta Electronics. It's my pleasure being here, sharing what Delta's view on the EV industry and solutions in e-mobility. Okay, electric vehicle is considered the key industry that can contribute significantly to the global net zero target. So, in fact, the life cycle GHG emission of the EV cars are only around half of those from internal combustion engine ICE cars. And if the EV cars are powered with low carbon electricity, the emission is only around a quarter from those from ICE cars. So there is a huge potential in carbon reduction in this industry. And indeed, many countries now have a policy to promote electric vehicle. In many ways, under their carbon reduction, national carbon reduction roadmaps. So you can see the projection of global EV stock will reach 250 million under the announced pledge scenario in 2030. But if we want to achieve net zero status, the numbers need to reach 380 million. So electrification of cars enables the transition from engines toward the powertrain systems, which include motors, motor drives, and batteries. This transition requires a lot of power electronic technologies. Additionally, as mentioned in PEGATRON's presentation as well, the trend of intelligent cars also demands a lot of power electronics components in systems such as autonomous driving, smart copy, etc. Of a vehicle. As a result, you can see the global automotive electronics market will reach 400 billion by 2028. So there's a huge business opportunities for ICT companies to enter. And Delta has cultivated in this industry for more than a decade. So Delta is founded in 1971, the same year United Arab Emirates established. So our mission is to provide innovative, clean, and energy efficient solutions for a better tomorrow. So both our business strategies and sustainable initiatives are all in line with our corporate mission. So with advanced power electronics technology, Delta has developed so many power systems with industrial leading energy efficiency, such as server power, telecom power system, and PV inverters. So with our power electronic technologies, Delta actually entered the electric vehicle industry in 2008. And indeed, back to 2005, our founder, Mr. Bruce Chen, imported Taiwan's first hybrid electric vehicle to understand and experience the energy performance of hybrid car and to know the technologies behind. So today, Delta's e-mobility solutions cover a lot of fields. First, we provide powertrain and power electronics components and fans for electric vehicles. We also have external charging systems for charging operators and microgrid-based solutions as well. And for e-scooters and e-bike, we provide motors and also powertrains. So let's see the powertrain system first. The powertrain system actually is the heart of an electric vehicle. So Delta began its EV business by developing DC-DC converters, which ensure correct voltage change of electric current within an EV. Then we expand our product offerings to include traction motor and traction inverters. Traction motor is like an engine of an ICE car. Basically, it converts the electricity from batteries to kinetic energy to make the vehicle move. And transfer inverter is a device that can control motors precisely. So now we have a comprehensive solutions in powertrain system. More than 70% of global top 20 carbons now are Delta's customer. Okay, with industry-leading engineering capabilities, we are able to integrate several standalone products into one single system. For example, we integrate onboard charger, traction inverter, DC-DC converters, and also electric vehicle communication controller into one integrated powertrain system. The integration reduce the use of a metal for external cases. As a result, the whole system can reduce 20% in modern and weight, which can contribute significantly to electric vehicles mileage. And we are working with our global customers to develop this kind of X-in-Y integrations powertrain system now. Okay, as I mentioned, a vehicle now needs a lot of power electronics systems. Those systems require a lot of power electronics components. So one of Delta's business group originally focused on making passive components for smartphone, laptops, and other consumer electronics. A few years ago, expand its product lines to automotive industry. Now you can see our power choke and power module are widely used in system like lighting system, infotainment system in an EV. The business group also received 7 Best Supplier Awards in automotive application in the past 2 years. Similar to our passive components, our fans and thermal management solution are widely adopted by major automotive companies. Those fans are used in autonomous driving system and also battery control system and also HVAC system within an EV. Okay, so regarding two-wheel electric vehicles, we also expect a significant growth in the coming years, and also especially in Asia. And we also think the estimate market size will reach around 70 billion in 2027. So in this field, we provide a powertrain and motors for e-bike and e-scooters. And for battery swapping stations for e-scooters, Delta also develop power modules for our customers to charge their scooters. So we can imagine that there will be a lot of electric vehicles on the road. So many questions arise. For example, if you are EV drivers, maybe you will think about where I can charge my cars. And for the EV charging operators, maybe you need to consider about how to optimize my investment and also expense to running EV charging station. And for utility companies, also you may need to consider about whether the existing power infrastructure can support the high demand from EV charging? Delta provides solution to these questions. So first, Delta has a wide variety of EV chargers, including AC chargers for residential and commercial use, and also DC quick chargers for road stops. And today, Delta already shipped more than 2 million EV chargers around the world. For example, we help EVgo, one of the largest public charging operators in the United States, build out several quick EV charging stations in the States. And we also supply AC chargers for Bali Island to support G20 summit a few years ago. So when people consider about installing new EV charging facility, the first question pop out in their mind should be whether the existing power infrastructure can support the EV charging on site. Indeed, the current the existing power infrastructure may be designed or established a decade ago. So they are not designed for match the high peak demand from EV charging, especially many electric vehicles charge at the same time. So we think in the near future, the EV charging infrastructure must be developed with microgrid solutions. You need to integrate EV charging, of course, PV system, energy storage, and also energy management software. But through this integration, we can optimize the use of electricity from renewable source, from grid, and also from battery to fulfill the demands from EV charging in this station. One of the successful experience I would like to share today is our EMEA headquarters in the Netherlands. It is a 35-year-old building. The facility manager there want to install 20,000 EV chargers to fulfill our employees' need of EV charging. But the problem is the power infrastructure of the building is very difficult to transform. And the manager there wants to avoid fines for overconsumption of electricity due to high demand of EV charging at the same time. So they apply our latest microgrid solutions. So you can see on this chart, the power demand occurs around 9 o'clock when people start to charging their electric vehicles. At the same time, the energy storage system starts to provide electricity to offset the surge in power demand. So as a result, we can reduce peak power demand contract capacity from over 100 kilowatt to 60 kilowatt. So we can save around 16% of in our monthly electricity costs. So Delta is not only for more e-mobility in our EMEA region, we actually coming to EPD 100 and also zero emission vehicle pledge. We promote e-mobility for all of our global operation sites. In 2023, we have 178 chargers in our 25 operation sites. We also have more than 60 electric vehicles or shuttles for company use transportation. Our target is to make all of our company cars and shuttles 100% electric vehicle. Not only for e-mobility, actually Delta's carbon reduction targets are also linked to international initiatives. For example, our RE100 target is to reach 100% electricity use by 2030. We also set up our net zero science-based target by 2050, which reduce scope 1, 2, and 3 carbon dioxide emission by 90% by 2050. So we will continuously work with our supplier and customer together to make it happen. So it's not possible to achieve net zero target by a single company's efforts. So that's why Taiwan climate policy is important, because it provides a platform to connect Taiwanese ICT companies and help us reach consensus and act together toward carbon reduction and our sustainable development goals. So together with our value chain partners, we hope to realize an intelligent, sustainable, and connecting world with Delta's solutions. Thank you.
Yeah, thank you, Johnny. Yeah, thank you. Have a wonderful talk. Please have a seat there. Yeah. Michaelowa, would you like to join us? Oh, okay. Maybe just we have a dialogue with Johnny. Actually, we have some people online to join us. Johnny make a very wonderful talk about the EV, and we have a different type. PEGATRON is the supply chain, maybe some of the company, and Delta, you have some charger, something around this. And I have a question to Johnny, because I remember I heard your Jesse is a CSO, Chief Sustainable Officer of the Delta Electronics. He mentions Delta Electronics spent about 14 years. You know, today you show the Bruce Chen. Your company import the first EV car. It's not EV car. It's a hybrid car. It's the first hybrid car in Taiwan.
Yes.
Okay, in year 2005. Oh, very early, and you start to invest it about 14 years. So this group, this team, 14 years, no big money. Right now, it boom up. How the enterprise have the face to do this? How? Because some company, most of the company just follow the trend in the recent 5 years. But Delta Electronics have about 14 years. Yeah, please.
Yeah, as I mentioned in my presentations, Delta's corporate mission is to provide innovative, clean, and energy efficient solutions. So I think my company just think about electric vehicles will be the future mega trend, in terms of climate change or carbon reduction. Yes. So I think at that moment, because a founder thing is a correct thing to do, and you will be a very big market. So that's a reason I think That's why we keep investing in this industry, because we believe e-mobility will be very comfort chain in the transportation. Yeah.
It's a long journey, and however, so right now it's not ended, right? We can see the bloom up of the EVs. So Delta maybe have another potential, another growth in the future.
Yes, as I mentioned, we have been developing electric vehicle solutions since 2008.
Yeah.
So we have experienced different phases along this journey. So at the beginning, we provide standalone products or components to automotive manufacturers, and then as we learn and increase our capabilities in engineering, we are able to provide motors and traction inverters to our customers. Now we are even able to provide XC1 highly integrated system to our customers. So today you can maybe many electric vehicles on the road maybe are powered by Delta's technology. So we think now we achieve some milestones in this business. But looking ahead, our vision is to provide so-called e-drive system, which integrate a gearbox, a motor, and traction inverter into one single system.
Yeah, wonderful.
Yeah.
Yeah.
And Delta is not an expert in making gearbox, so we need to achieve this. We need to work closely with our partner to make vehicles entirely driven by Delta.
Yeah. Is this possible in the future have a Delta car in the future?
No, we are not focused. We don't focus on making the entire electric vehicle.
Okay. My second question is to let everybody knows, because the Delta is the first mover to attend the COP meeting by the company resources, the Delta Foundation. And I remember it's from year 2007, right? It's a very, very old story. And even I remember in COP21, COP, in year 2016 in Paris. During that COP21 and in Paris, and Delta have a very huge exhibition during that times. And how many COP you have attended before already?
I think maybe this is my fifth one.
Fifth one. Okay, wonderful. And what's the meaning for the COP? Because you are the first company, and lots of our ICT industry follow the Delta, especially the president of the Delta Electronic is also the chairman of the TCP. And I'm wondering, what's the importance of the enterprise to attend the COP? Because some people will think, okay, it's a government official negotiator to attend, and also for some NGO. But the Delta Electronic is the first mover from the enterprise to join. What's the importance of the COP for the enterprise?
Okay, participating in COP events actually provide us with an excellent platform to engage or collaborate with renowned global NGOs such as the Climate Group and Women Business, etc. For instance, as Dr. Pons mentioned, back to 2015 during COP21, Delta committed to carbon reduction initiatives of women business. And this was the starting point for Delta aligning its carbon reduction targets with international initiatives. So we think is quite important for Delta. And also, we think we also want to let people know there are a lot of technologies available for to tackle climate change challenges. So we have been organizing climate change seminar events for years, and for this kind of events, we shared latest observation from COP and also latest climate change studies with people. And in our last event, we have over 1,000 participants, either virtually or on site. So we look forward to continuously creating past impact through this kind of activities.
Yeah, for the enterprise, if they want to go to the green to attend the COP, to observe the COP, is very important, right? It's very. It's just a door to you should, if you want to do this, you should open the door. The door will be the COP, right?
Yeah, because yeah, there are a lot of carbon reduction opinion leaders here. Then if you can connect with them, then you can know more ideas or knowledge about the global carbon reduction trends and maybe a new technology as well.
Yeah. So it's your 5th COP. I'm wondering, by my experience, it's my 11th COP. And but this 5 COP already changed a lot. I remember in the beginning in COP18, is my first COP, is in Doha. Because during that time, all the people, the participants, just only less than 10,000 people. I guess less than 10,000 people. 10,000, only the negotiator and NGO, totally. But right now, this year, maybe 100,000, probably. I don't know the final people to join. So what's your thinking about the last 5 COP, the transition from the COP? Do you have any experience you want to share to the public?
Well, I have seen more and more companies engaging in COP activities, actually. And I also noticed there's a trend of establishing corporate alliance aiming for working together on fighting climate solutions, and also maybe reducing Scope 3 carbon dioxide emissions. So I think it's a good way, because when you talk about Scope 3 carbon emission reduction, you need to co-work with your value chain partners. So yeah, so I think if more companies participate in this kind of events, the chance of collaborations will be even higher.
Yeah. Your president, Yang Shih, and is also the chairman of the Taiwan Climate Partnership. He always mentioned to us, Dr. Peng, we should be a very solid organization, not to do the greenwashing. So I remember when we first have a report to him, and he suddenly told me, Dr. Peng, we should follow the United Nations no greenwashing criteria. So what do you think? The no greenwashing, do the right thing is very important. But here, not some of the greenwashing things, I think. But we are trying to do the solid things. Do you have any kind of the comment about this to avoid the greenwashing? Not to here to show himself to be a green one. Yeah.
So basically, you need to follow your commitments. Right? Because I think many companies nowadays have announced their commitments toward carbon reductions. But at the same time, you need to have clear roadmaps and maybe disclose the milestones or achievements periodically. Yeah, so I think it's quite important. You need to communicate with other parties transparently about your achievements in carbon reduction.
Yeah, okay. Thank you, Johnny, and give us a wonderful talk and let us know the situation. So thank you all of the speakers here today. Thank you very much. Thank you.
Thank you.
Thank you. Bye-bye. Thank you. Bye-bye.